Hey guys, today we're going to look at the dot product again, but this time with algebraic vectors. Remembering that this is just the version of the vectors where we're breaking it down into components rather than just doing magnitude and an angle. So first of all, we're going to look at the dot product of standard unit vectors. So this is your I, j, and k. Okay. If you have the dot product of any two that are the same, okay, it's just going to equal 1. Okay, and 1, and 1. And if you have two that are different, then it's actually just going to equal 0. Okay, and I'll do a quick little proof here. I'm not going to do it as a full proper proof, but if we just look at, we'll focus on the I. If we have I times I, okay, and we do this the way we did it yesterday, then we'll say that this is the magnitude of I times the magnitude of I times cos, and then the angle between I and I, which would, because it's the same, would be 0 degrees. Okay, and so that would just equal 1 times 1 times 1, which of course equals 1. Okay? If we were to do any two that are different, so we'll just use I and j here. So we'll say I dot j, and this would be interchangeable. If you used k or j and k or something like that, it wouldn't make a difference. Okay, but we would have the magnitude of I times the magnitude of j times cos, and then the angle between I and j would be 90 degrees. Okay, and so what you get there is that's 1 times 0, and so the answer is just 0. Okay? All right. So, the dot product of two algebraic vectors. Algebraic vectors. All right. So the formula we're going to use here. So you see, I've got these two vectors, a and b. Okay, and they've got I've just broken them up into their components. So you've got ax, ay, az, and you could write this either in this form or in this form. It doesn't make a difference. It works the same. Okay, the idea here, and this is actually, I believe this is a little easier than yesterday's. You may have a differing opinion, and that's okay. But the dot product is just, so you take the x components, so we have ax, okay, and you're just going to multiply it by bx. Okay, so you multiply the x components, and you just add it to the multiplication of the y components and the z components. And that's it. Okay? So in other words, add your x's, multiply your x's, multiply your y's, multiply your z's, and then just add those three numbers together. And that's all you do. If, of course, you're doing two-dimensional vectors, you would just not have this term here. Okay? This part would be the same. Okay, but it works the same either way. Okay, so what we're going to do then is I'm going to prove standard unit vector using the student, whatever. So here we go. All right. Let's see. So how am I going to do? I'm just going to go. Yeah. All right. I know what I'm going to do. So we're going to just say. So I'm just using the same a and the same b. So to do a dot b, okay, we're going to go like this. We're just going to say this is a x times I. Okay, plus a y times j plus a z times k. Okay, and I'm just going to do the dot product of that with b I plus by j plus bz k. Okay. And so how I can do this is I can just use my properties that we talked about, and we're going to have ax bx times I dot I, okay, And then we would have plus AY BY times J dot J. Okay. Plus, and this is just using the properties that we talked about yesterday. I mean, we talked about them quickly, but it works the same. And that's times K dot K. Okay. So from there, I dot I, J dot J, K dot K, those all just, oh sorry, you know what, I'm missing half the terms. What am I doing? Okay, so we're using the distributive property. So there's those ones, and then there's also, those are the important ones. That's sort of why I glossed over this. So then we would also have, we'd have AX BY times I dot, that'd be J. Okay, and then we have, oops, plus AX BZ times I dot K. And I hope you can see where this is going here, because the idea is that a lot of these terms are just going to disappear. So AX, whoops, nope, that's not right. Sorry, so we want AY now, times BX, I missed that one, so that would be J dot I. I'm just going to go under here, plus, I missed a plus here, AY times BZ times J dot K. Plus, what have I got left? I've got AZ times BX, which is K dot I. And finally, plus AZ times B. I'm putting dot there. I shouldn't be doing that because it is just regular multiplication, because those are just scalars, remember. And then we would have K dot, oops, nope, that should be a Y. Sorry. Here, I'm just going to do this. Y. My erasing skills aren't good enough for that. Times J. Okay. So the idea here is that if you look at what we talked about at the beginning, this equals 0, okay? This one equals 1, that one equals 1, that one equals 1. But this one, this one, this one, this one, all those ones, all equals 0. So that equals 0, 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 that equals 0. So they're all gone. And all you're left with is the actual formula then. We've just got, because this one, sorry, I glossed over, this is 1, that equals 1, that equals 1. So all we're left with is the AX, oops, AX, BX, plus, I don't know why I have a bracket there, AY, BY, because then that was multiplied by 1, and then AZ, BZ, and then that was multiplied by 1. I just closed the brackets because I put one at the beginning. There you go. So that's it. So that's sort of a sloppy proof that I did there, but there you go. I'm going to skip the proof with the cosine law. I'll let you do that on your own if you choose to, because I do want to get into some of these examples and show you how this is fairly straightforward compared to the one we did yesterday anyway. So for instance here, we're going to have A times B, or with the dot product. So you're just going to have 1 times 0, okay, plus negative 2, negative 1, plus 0 times 2. Okay, obviously the 2 that equals 0 cancel out, and we're just left with a positive 2. All right, for this one here, okay, A dot B. So this time I've written it with these unit vectors, and it doesn't make a difference. Remember, you're just looking at the coefficients. Okay, so we've got negative 1 times positive 1. Okay, those are the coefficients of the i's, plus coefficients of the j's. We got 2 times negative 2, plus, and then we've got 0 times negative 1. Okay, so we're left with negative 1 minus 4. So minus 5. Okay. And then finally, I tried to throw you a curveball here and do them in different notations, and it doesn't make a difference. Okay, so you just have your negative 1 times negative 1, and then we've got plus 1 times 2 plus negative 1 times, oh, I ran out of room, times negative 2. There we go. Piece of cake. All right, so we're left with 1 plus 2 plus 2, which is 5. Okay, and there we go. All right. So, if we want to find the angle here, okay, then what I'm going to do is I'm going to take the version we did yesterday and the version we did today, and I'm just going to combine them. And what I'm going to do is I'm going to come up with this this equation here where it's just cos theta. Cos theta is equal to, and what it would be is the dot product of A, B over the magnitudes multiplied. So we get the magnitude of A times the magnitude of B. So that's what it would be. But now that we know a way to simplify that one with components, combined with us using the formula we use for magnitude, this is going to give us the much better version of this, which is that we'll have AX BX plus AY BY plus AZ BZ all over the square root of AX squared plus AY squared plus AZ squared. And then we multiply that by the magnitude of B, which is just BX squared plus BY squared plus BZ squared. Okay, and that's it. All right, now there are a couple of things to note about this, which we'll pull up over here. Okay, there we go. If cos theta equals 1, then A and B are not only parallel, but going in the same direction. Okay? There we go. So let's zoom in so it's a little neater. There we go. Okay? So they're parallel and have the same direction. If cos theta is negative 1, however, then they are still parallel, but they're going to be going in opposite directions. Okay? If we have cos theta equaling 0, then A is going to be perpendicular to B. Okay? Yeah, and then if cos theta is greater than 0, it's going to give us the theta is going to be between 0 and 90. Okay? It is between 0 and 90 degrees. Okay? And then finally, not surprisingly, we follows that the angle would be between 90 and 180 if we get a number that is less than 0, or a negative number. Okay? All right. So I'm trying to, yeah, okay. There we go. So we're going to take a look at example 2 here. Okay. So I've got A and I've got B, and I want to find the angle between them. Okay, so I'm just going to use my formula, and I'm going to cheat a little bit, and I'm just going to, when I write out the formula, because I don't want to write out that whole thing, I'm actually just going to write out the first version of it. So I'm going to say cos theta, and this is a trick to get your communication marks without having to write too much, is I don't actually have to write out the formula for these individual parts. I can just write it like that, and then I can just go straight into how to do that, okay? So I'll have 1 times 0 plus 0 times negative 2, and then plus negative 1 times 2. Let me just zoom out and make sure that I did that right, because I can't actually see the question anymore. And I did. Did I? Oh, I feel like I messed up. What's wrong here? Something's wrong. Did I do the wrong one? Negative 2. Yep, I did the wrong one. Okay, sorry. This is the problem with zooming in. So that's wrong, and that's wrong. I'm just going to redo it. Okay, let's see. Let's try that again. So we got 1 times 0. That one was right. Okay, and then we had, oh, there we go. Okay, so it's negative 2 times negative 1, and then plus negative 1 times 2. Okay, there we go. And then we're going to divide by the square root of, we've got 1, I'm just going to skip a little step here. I'm going to say 1 plus 4 plus 1. Okay, and then we'll have 0 squared plus negative 1 squared is 1, and plus 2 squared is 4. Okay, so I'm left with, well, let's see. So on top we got 1 times 0, that disappears. Negative 2 times negative 1 is 2. And then negative 1 times 2. So actually what happens here is that the top equals 0. And so we don't even actually have to figure out the bottom. Okay. And so once you've got the cos theta equals 0, then we know that theta is going to equal 90 degrees. Okay. And so in other words, vector A is perpendicular to vector B. All right. So I want you to try the next 3 questions on your own. Okay, they use the same ideas. Remember, I mean, you should know your terminology by now, but remember perpendicular means they meet at a 90-degree angle. But yeah, so I want you to give those a whirl, and we'll take them up in class. So until next time, go Sabres.